Welcome to today's paper reading. Today's paper is titled, Can Large Language Models Reason and Plan? This paper, authored by Subbarao of Kambhampati from Arizona State University, explores the reasoning and planning capabilities of large language models, published in the Annals of the New York Academy of Sciences. The research aims to evaluate whether large language models can reason and plan. Key findings indicate that while these models exhibit limited reasoning capabilities and can perform basic planning tasks, their effectiveness is highly context-dependent. These findings have significant implications for AI development, potential use in educational tools, and areas for future research. The author of this paper is Subbarao of Kambhampati, who is affiliated with the School of Computing and Augmented Intelligence at Arizona State University. The paper appears in the Annals of the New York Academy of Sciences, with a specific DOI for easy access. The author's contact information is provided for further inquiries. Large language models, LLMs, can be conceptualized as giant non-veridical memories, functioning like an external system one. These models are trained on vast web-scale language corpora, enabling them to perform universal approximate retrieval. Unlike traditional databases, LLMs reconstruct text probabilistically, word by word, which means they cannot guarantee the memorization of complete answers. This probabilistic nature is both a boon and a bane, contributing to their creativity and potential for hallucination. Despite their impressive capabilities, LLMs are not inherently designed for principled reasoning, which often involves computationally hard inference. The trend of viewing LLMs as capable of zero-shot reasoning tasks reflects the current era of AI, where observational studies of these models' capabilities drive advancements, akin to an ersatz natural science. Figure 1 provides an informal perspective on how large language models, LLMs, can be seen as a giant external non-veridical memory, functioning as a pseudo-system one. This view highlights the LLM's role in processing and retrieving information in a manner that mimics human cognitive processes, particularly the intuitive and rapid decision-making associated with System 1. The figure emphasizes the LLM's capability to approximate retrieval and generate completions based on probabilistic models, which aligns with the characteristics of non-veridical memory. This conceptualization underscores the LLM's potential in tasks traditionally linked to System 2, such as planning and reasoning, while acknowledging the limitations in guaranteeing the correctness of its outputs. In the summer of 2022, the research group aimed to empirically evaluate GPT-3's planning capabilities using instances derived from domains typically used in the international planning competition, including the well-known blocks world. The results were contrary to the anecdotal claims about the planning abilities of large language models, and upon public release, these findings garnered significant attention within the AI community. The related work section discusses the claims about large language models, LLMs, abilities to reason and plan. Initial tests on GPT 3.5 and GPT-4 showed that while there was some improvement in accuracy, particularly in the blocks world domain, GPT-4's performance significantly dropped when the names of actions and objects were obfuscated. This suggests that the improvements might be due to better retrieval abilities rather than actual planning capabilities. Two main techniques to improve planning performance are fine-tuning and back-prompting. Fine-tuning did not show significant improvements in our experiments, and back-prompting, whether manual or automated, raises questions about the source of the improvements. This section also highlights the importance of external verification to ensure the correctness of LLM-generated plans. It emphasizes that while LLMs can generate potential solutions, these need to be verified by external means to avoid false positives and negatives. The human in the loop remains crucial for ensuring the accuracy and reliability of the final solutions. Figure 2 illustrates how the claimed reasoning capabilities of large language models, LLMs, can be attributed to the subconscious, iterative prompting by humans in the loop. This phenomenon, often referred to as the clever Hans effect, suggests that the LLM is generating guesses, and it is the human, with knowledge of correct versus incorrect solutions, who is guiding the LLM's output. The accuracy of the LLM's responses, if any, is thus credited to the human in the loop, rather than the LLM itself. This framework is particularly relevant when the human in the loop is knowledgeable enough to verify the reasoning or planning problem. The figure humorously characterizes the situation, highlighting the role of human intervention in the perceived capabilities of LLMs. Figure 3 illustrates the concept of large language models, LLMs, as an approximate knowledge source trained on a vast array of civilizational knowledge. This perspective suggests that LLMs can effectively replace the role of a knowledge engineer in traditional knowledge-based AI systems. The figure highlights how LLMs can provide problem-specific knowledge, albeit with relaxed correctness requirements. This approach is akin to a new trend in AI, where explicit knowledge gleaned from LLMs is integrated into systems. The LLM modulo framework is introduced as a principled method to leverage this knowledge for planning tasks, addressing the challenge of how to plan with a doddering know-it-all ready to provide any kind of knowledge. In conclusion, the author finds no compelling evidence to support the belief that large language models, LLMs, possess reasoning or planning capabilities as typically understood. Instead, LLMs perform a form of universal approximate retrieval, which can sometimes be mistaken for reasoning. There is a rich irony in the AI community's terminology. Providing a computer with knowledge of a toy world for solving new instances is derisively called good old-fashioned AI, whereas capturing all human knowledge from the Internet and training LLMs on it to provide task-relevant knowledge is termed modern AI. Despite this, LLMs excel in idea generation for tasks involving reasoning and can effectively support reasoning and planning within LLM modulo frameworks. Given their impressive approximate retrieval abilities, there is no need to ascribe questionable reasoning or planning capabilities to them. Thank you for watching.